Okay, this is the second video on the numericals on consistency limit. Okay, first numerical we had not finished totally. We were still supposed to find out the shrinkage ratio. Okay, the reason I did not give you all the answer that time because we had not completed the theory on shrinkage ratio. Okay, so what is shrinkage ratio? It is defined as the ratio of, it's the ratio of, one can write down, change in volume expressed as percentage of dry volume. Okay, 2, it's the ratio of this thing. Okay, change of the to the corresponding change in moisture content. So what do you mean by this? Okay, so you have a soil sample, let's say, which has a moisture content W1 and W2. So when there is a volume change at these two moisture content, okay, you take the percentage of these volume change with respect to dry volume, okay, and divided by this change in moisture content. So by equation, mathematically, this is written as V1 minus V2 upon VD, percentage of dry volume. So percentage you have to express it into 100 by change in the moisture content. Over here, W1 and W2 are fractions. Okay, so now what is W1 and W2? These are the moisture contents. So what is W1 basically? It will be, it's a moisture content, so mass of water divided by mass of solid. So I'll write this as mass of water at, let's say, first stage, at one particular moisture content divided by mass of solids. You all remember the equation for moisture content? Yes, so divided by mass of solids. Okay. Now mass can be written as, mass can be written as volume into density. Correct? So volume of water into its, now this is weight, so this will be weight only. Actually this is W1, what is it, moisture content. So if I'm writing mass, then I will be multiplying by rho or unit weight. When I'm writing mass, I have to multiply it by density. Okay, so if it was weight, then I would be multiplying by gamma, unit weight, right, divided by mass of solids. I'm writing this as ms. Now, volume of water at stage 1, I am writing it as V1 minus Vs divided by then Ms, okay, into 2W. Okay. Similarly, what I'll get W2 as moisture content at stage 2, I will get it as V2 minus Vs. See, this derivation is not important from the point of view of your exams. The derivations are not usually asked. But you should know how various quantities are related: mass, volume, weights, shrinkage ratio, all this. Okay. So you have W1 is equal to V1 minus Vs upon Ms into rho W. Similarly, you have W2 is equal to V2 minus Vs upon Ms into rho W. Right. Now, if I want to write this W1 minus W2, what will it look like? How do I simplify this? W1 minus W2 will be V1 minus V2 upon MS into rho W, correct? This WS, this VS and VS will get cancelled, correct? So now shrinkage ratio will be given as V1 minus V2 upon VD. This thing, I think the cursor is not visible. So write what is written here. Okay, here. Same thing. Okay. 100 I'm cancelling. So I'm writing V1 minus V2 upon VD. And this W1 minus W2, which is this, I am writing it inverse because this comes in the denominator, into MS upon V1 minus V2 into rho W. So this will be given as MS upon VD into 1 upon rho W. Okay, what is MS upon VD? Mass of solid upon dry volume. Can I write it as mass of solids upon dry volume is rho D, correct? Divided by rho W. So anything that is written in terms of densities can also be written in terms of unit weight, correct? Okay. Therefore, I am writing it here. Therefore, shrinkage ratio can also be written as gamma D upon gamma W. Understood? Now, coming back to your problem, what was your problem? You are told to find shrinkage ratio, but neither densities nor unit weights are given. So how will we find shrinkage ratio? Do we have any three volumes and corresponding moisture contents? Yes, we do. We have a volume corresponding to liquid limit and we have a volume corresponding to plastic limit. So we have one volume, second volume, and we have their corresponding moisture content. Correct? So we will use that and find out our shrinkage ratio. So I will just write down the equation. SR, this is what we had solved last time. SR will be V1 minus V2 upon V, okay, divided by W1 minus W2. So I'm writing this as V1, I'm taking it as VL, V2 I'm taking it as VP, dry volume I'm writing it as VD, which is otherwise also VD, okay, divided by WL minus WP, correct? So this I rewrite as VL. We have everything in terms of VL only, no? So 1 minus 0.88 into 100, correct? Upon 0.66 VL. VD is how much? 0.66 VL, correct? We had got this here. VD is 0. We are writing everything in terms of VL, okay? Into 33 minus 25, okay? Fine. This will be is equal to 2.27. So your shrinkage ratio is 2.2. Okay.